Okay, so I did web assign 2B, number 16, and it said a basketball player who is 2 meters tall is standing on the floor 13 meters from the basket, and if he shoots the ball at a 35-degree angle with the horizontal, at what initial speed must he throw so that it goes through the hoop without striking the backboard? The basket height is 3 meters, 3.05 meters. So first we'll draw a picture. So this is the person. His height is 2 meters. The distance between him and the backboard is 13 meters. And the height of the hoop is 3.05 meters. Then he throws at an angle of 35 degrees. Okay. So we know theta is 35 degrees. We know his vertical displacement of the ball would be the final position minus initial, so it would be 3.05 minus 2, which would be 1.05 meters. And we're looking for its initial velocity, the initial velocity we would need in order to get over there. So we'll use this equation, this kinetics equation. Difference in y is equal to the initial velocity times time plus 1/2 acceleration times t squared. So we know in a vector, so for vectors, we know that vectors are of x and y components. So this is the net, this would be the net, so for v net, and this would be its x component, and this would be its y component. And we can and based on the angle, we can break them up basically into x and y, and we can use the x and y components to find the v net. So the equations we use for these, vy would be equal to v sine of the angle, and vx would be equal to v cosine of the angle. So we use these two equations. And so for our problem here, we know that the velocity in the y direction would be equal to the initial velocity times cosine times theta, which for us is 35. And then for Vx, for the velocity in the x direction, we know that it's the initial times sine. Oh wait, I messed that up. Sorry. Vy times sine, then Vx cosine 35. So now, we can plug those in. So for the time, it did not give us a time. So this is a part that trips up some students when they're doing this problem. Is that the time would be equal, that so distance equals rate times time. So if we just do some algebra, we can see that time is equal to the distance or the displacement or the velocity, which is initial for us. And so the time in this case would be equal to the delta x, which would be, in this case, it was 13, the distance between the person and the backboard, so 13 meters, over the initial velocity in the x direction. This is also a place where some students mess up, is where they put the initial velocity in the y direction, but for this case it would be the x. So, and that up here, as we saw, was equal to vi, the initial, times cosine 35. So we can plug this in for t in our equation over here. So we know delta y, which was 1.05, is equal to the initial velocity, which we don't know yet, times time, which we found over here. So we're going to plug this in. 13 meters over VI cosine 35 plus 1/2 times the negative 9.8 acceleration times time again, and this time the time will be squared. So this is how we set that up, and then we're solving for the initial velocity. So doing some algebra, we can clean this up. So for this first part here, when this VI will come into it'll get multiplied to this part, and then the VI's will cancel, leaving 13 meters over cosine 35. And over here, some students forget to square. The square will be distributed to the 13 and to the bottom. So remember that. And then once we clean it up, we can say 1.05 minus 13 over cosine 35 is equal to negative 4.9 times 13 squared and over VI cosine 35, and then that is squared. So I just cleaned up this side, and then I just brought the square, I just squared the top and the bottom, and then once you clean this up, VI at the end will end up being 12.38 meters per second. That's the initial velocity that he would have to throw the ball at in order for it to reach the hoop and not hit the backboard. So some general problems while solving this would be forgetting to put in the correct initial velocity when you're solving for t, and also forgetting to square the top and the bottom of this. And remember that you're not squaring the 9.8 or the half. You're only squaring the 13 and the VI cosine 35. So, and that would be your answer.